We've been working on a major upgrade to Daft's distributed execution, and today we're excited to introduce Flotilla, a redesign that makes multimodal data pipelines scale effortlessly. Imagine you're tasked with ingesting PDFs for a search application. Each one needs to be downloaded, parsed, embedded, and stored in a vector database. On a small dataset, this is fine on your laptop, but at scale, think of millions of PDFs, the cracks are going to show. You'll quickly find that you need more GPUs to handle the embedding load. Bigger boxes aren't the answer because they are still bottlenecked on I/O. That's why you need to go distributed. But how do you do that? You can reach for an existing tool like Spark and stitch together some pandas UDFs. But Spark doesn't understand multimodal workloads. A row could be a 50 or 100 megabyte PDF, and you end up endlessly tuning partition sizes and memory configs just so you don't But even after getting your partition size right, you still don't get the throughput you want because Spark simply doesn't optimize for these kinds of workloads, these kinds of heterogeneous workloads with CPU, I/O, and GPU. Downloading is I/O bound, text chunking is compute bound, and embedding is GPU bound. Well, if not Spark, you could build your own pipeline with Python scripts on some workers, but then you lose everything that makes a query engine useful: declarative APIs, query optimization, fault tolerance, and observability. That's why we built Daft, a distributed query engine that actually understands multimodal data. In just a few lines of data frame code, you can download PDFs, parse them, embed them, and write the results to a vector DB. If you run this code on a laptop, Daft's local execution engine, Swordfish, will run it efficiently for you. Instead of huge partitions like in Spark, Swordfish works on small batches. Pipelines I/O with compute keeps your GPUs fed without blowing up memory. And today, we're bringing Swordfish to the cluster with Flotilla. Each node in the cluster contains a Swordfish worker, which manages its local CPU, GPU, disk, and network resources. On the head node, a scheduler and worker manager coordinates tasks, retries failures, handles the life cycle of workers in the cluster. When a worker receives a task, it runs it on Swordfish, just like how you would run Daft on a single machine. What does this unlock? Terabyte-scale multimodal workloads containing millions of images, PDFs, or audio files complete efficiently without retries. Memory usage decreased significantly, meaning you can use smaller and cheaper machines. We benchmarked Flotilla against Spark and Ray data across 4 real multimodal pipelines: audio transcription, document embedding, image classification, and video object detection. And we found that Daft was 2 to 8 times faster than Ray data and 4 to 18 times faster than Spark. In one highlight, our video object detection pipeline of over 1,000 videos finished in just under 12 minutes, where Spark took over 3 hours. And this is just the beginning. We're working on improvements to the engine across the board: better shuffles, better GPU pipelining, and a new Daft dashboard for real-time observability. If you're curious about how all this works under the hood, check out our architecture docs at docs.That.AI. Ready to get started? Pip install Daft today.